Today's job is a damaged hub from a wheeled excavator. From what I can see at this point, this thread portion has broken. I cannot see much of what's going on inside the hub, so I'm going to give it a clean to better investigate. Alright, so as mentioned before, this threaded portion on the stub has broken out. I believe that's probably the cause of the hub failure. Another thing I picked up is this diameter on the stub does not suit the bearing. I have measured both of the bearings that came out the hub and they have the same dimensions. I have also picked up that this stub has been repaired before, so my guess is a sleeve came off of the stub when the hub failed. Okay, the next damaged part is the nut that holds everything together. Take a look at this. The threaded portion that broke off the stub is still sitting in the nut. The nut is also full of terrible looking welds. They obviously welded the nut to the stub to lock it once it was fastened in its position. Going on to the hub, the seal journal is damaged. Fortunately, the bearing cups were still seated tight in their journals, so I don't need to repair anything there. But I am going to begin this repair with the seal journal on the hub. The material of the hub and stub is cast iron. I could do this repair by welding up the damaged portions, then machining them back to size. But welding cast iron is headaches. I'm going to sleeve the hub. If you're not with me on the repair, what I've just done is machined out the material that I'm going to be filling with a sleeve. I am machining the sleeve from a piece of off-cut hollow bar. I'm machining the outside of the sleeve to a shrink fit size that suits the inside diameter of the hub I machined. For the inside diameter of the sleeve, I am not yet machining to size. I am just taking rough cuts. I will cut it to its final size once it has been inserted in the hub. The reason for this being is because the inside diameter of the sleeve will slightly shrink once it has been fitted in the hub. Alright, for now that's all the machining I need to do on the sleeve, and it now needs to be fitted in the hub. As you can see, the sleeve does not yet fit in the hub, so I'm going to use some heat to expand the inside diameter of the hub. Before I drop the sleeve in, I measure to make sure it has expanded enough. It has, so let's fit the sleeve. Note how the sleeve is still loose, but as the sleeve heats up and the hub cools down, it binds. Okay, let's take the hub back to the lathe. I clocked up the hub with my dial indicator on the bearing journal, and then a machined area on the face of the hub that never took damage. This will ensure that the seal journal runs true with the bearing journal. Okay, I am now machining the sleeve to the finished size to suit the seal. And that's the seal journal on the hub repaired. To finish it off, I gave it a quick clean with some sandpaper. Alright, so I've fitted the two bearing cups. I have done this because I need to measure for a spacer that fits between the two bearing cones on the stub. I'm going to show you the spacer a little later. For now, I'm making a new nut. Repairing the old nut is not worth it. The threads are damaged and it's full of welding. I can fabricate a new one in just about the same time. That's the outside and inside diameter of the nut cut to size. I now need to cut the internal thread. Internal thread cut. I can now part the nut off and take it to the milling machine. I'm going to cut 4 slots into the nut. I could use the dividing head to cut the 4 slots 90 degrees from each other. But these slots are not too crucial and I already had the vise set up in the milling machine. This method will be good enough. And that's the final slot complete. That's all I'm doing to the nut for now. Let's take it back to the other parts. Okay, for now I'm done with the hub and the nut. It's time to move on to the stub. So as mentioned before, I need to sleeve the bearing journal on the stub. Now for the more interesting part. For the broken thread portion, I'm going to machine these teeth down and move the threads to that portion. Let me explain why I'm doing this. As mentioned before, this hub is from a wheeled excavator. The excavator used to be driven with all 4 wheels. Parts could not be bought when the hub previously failed. This drum used to house the planetary gears. But when I stripped the hub, there were no planetary gears. Those planetary gears would have been driven by a sun gear, that would be mounted on the drive shaft that came through the center of the stub. And then the planetary gears in the drum would have fitted in this ring gear. If you follow my videos, you might have seen a repair I did on a hub that is still functioning properly from the same excavator. So I'm not going to go into too much detail of how the hub functions. This hub is actually one of the two that still function properly. And I had to repair these parts because new ones could not be bought. Anyways, I don't want to get too far carried away here. So let's focus our attention on the hub that is currently at the workshop. So as you saw on the hub that is still functioning properly, this ring gear is fitted on the stub. But because the excavator is now 2-wheel driven and not 4-wheel driven, we no longer need to use this ring gear. So long story short, I'm converting the whole final drive design in the hub to a basic axle and hub setup. So with that being said, I don't need to repair the broken out threaded portion on the stub, because the new nut I made will not screw onto that portion anymore. It will screw onto the old gear portion I'm going to machine down to suit it. Okay, let's continue with the job. I hope that makes sense to you. I just need to remove a blank that was inserted on the back of the stub, where the old hub seal was seated that sealed on the drive shaft. I'm doing this because I'm making a jig that fits through the stub to position and secure it in the lathe. The material I'm using to make the jig is from an old grid roller towage that snapped. I am machining its outside dimensions to suit the inside dimensions of the stub. Once the machining on the stub was complete, I needed to drill and tap a hole for a bolt that will secure the stub on the jig. And that's the jig complete. I just need to slide the stub over and secure it with the bolt. And that's the stub set up and running true in the lathe. I can now begin the machining on the stub. So the old threaded portion will no longer be used, so I'm machining that away. Just want to mention, it's evident from the chips I'm getting that this material is cast iron. The old threaded portion is now machined away. I'm now going to machine the spline portion down to the correct diameter to suit the nut. Okay, I'm on size here. I'm going to machine the bearing journals for a sleeve. Note how the shavings I'm now getting from the material has changed. It was suddenly extremely hard. This is because the stub was previously repaired. In the previous repair, this portion was welded up, and that's the reason for the harder material. Notice with the more material I machine away, the softer the material gets. Here you can notice a slight change of color on the stub from the welding. Anyways, I've removed enough material. I'm now going to machine the sleeve. I am not yet machining the outside diameter of the sleeve to size. I'll be doing that once it has been fitted to the stub. However, I've machined the inside diameter of the sleeve to a shrink fit size for the stub. Let's go expand the sleeve with some heat and fit it to the stub. Righto, so the sleeve is fitted to the stub. I now need to machine the diameter to the correct size for the bearings. So that's the bearing journals complete. I'm now cutting thread for the nut. And that should be the final cut. Let's test it with the nut. And the nut fits perfectly, so that's all the machining on the stub. I'm just going to give the stub a quick clean with the wire brush. And that's that. The stub looks like a functional part again. I did not record this, but I fabricated the last two parts I needed. The one was a spacer that fits between the two bearings, and a washer that is pressed against the bearing by the nut. So having a closer look at the stub, this portion is the seal runner. Then a bearing sits here against the shoulder, then the spacer, another bearing, then the washer, and then the nut. So I'm now going to go ahead and begin the assembly. Because the only mechanical parts in the hub are now bearings, the hub will no longer be filled with oil. The bearings will now be running in grease. I'm now going to move on to the press to complete the assembly. So that's the hub with the seal and the one bearing. Now it's the spacer, then the second bearing, which I'm going to press on and fit the washer at the same time. And then lastly, it's the nut that secures everything together. I'm just giving the nut a couple shots to ensure it has bottomed out. And that's the hub assembled. I did not record it, but before assembling the hub, I drilled and tapped a hole in the nut for a locking bolt. I am now going to drill through that hole and into the stub. Once the hole was drilled, I ran a tap through the nut that already had thread and tapped the stub. And lastly, I put some Loctite on the bolt and fastened it. I do not want this bolt coming out and the nut turning loose. That will result in the hub failing again. Okay, so that's the hub complete. This gear can go to the scraps. The customer will add more grease because they will be fitting the drum to the hub assembly when they fit the wheel, because the wheel nuts hold the drum on. I just need to put the cap back in and my job is complete. Thanks for watching. Your support is much appreciated. Cheers. Check you in the next one.